Alarm templates. We know that in a DataMiner system, alarming is of course very important. And we want to have accurate and correct alarming. And that's what we can configure in the alarm templates. We will discover that you have a lot of features there and a lot of goodies that allow you to make sure that you have correct and accurate alarming. Let's take a look at that. So in the alarm templates module, we will first take a look at an introduction, and then we will dive into immediately creating a brand new alarm template. Once we've done that, we will go into the details and make sure that we fully understand the editor. It has a lot of features to it. We'll start with the basics and then go through all the different possibilities. So that's going to be the biggest part of this video. After we went through all the possibilities, we will also then look at how to assign that to your elements, and we will wrap it up with the alarm template groups, which allow you to basically combine several alarm templates together and stack them on top of each other, you could say, to create a group. So first of all, an alarm template. That's basically an XML file that allows you to define which parameters needs to be activated for alarming, and also which thresholds you, of course, want to add in there. When does your CPU load, for instance, or your bit rate or your signal level, when does it need to go into alarm? So we will be able to see all the parameters in there. We will be able to activate it and define all the thresholds and a lot more. So we will, of course, distinguish analog parameters. That's like a CPU load or a bitrate or a signal level. So we can set various thresholds when a warning starts or a critical alarm starts. And for the discrete parameters, we basically have the possibility to say an on-off kind of parameter, or if the signal is locked or not locked when we generate an alarm and which severity it needs to have. Remember that not all the severities need to be used. You can just say, like, I'm only going to use warning and critical and not the minor and the major, for instance. On every parameter you can choose so. Note that a alarm template is basically an XML overlay on top of your driver. So we already discussed the drivers, and we said, like, okay, it's good not to touch the drivers because you can then easily upgrade it to a newer version. And if Skyline provides you with a driver and provides you tomorrow with an upgraded version, then your changes would not be lost. So, but we do want to change certain things. We already discovered in the protocols module that you can basically create an overlay, an information template to overrule certain things like a name of a parameter. In here, the alarm template is a little bit similar, where you can basically define your own perspective, your own view on which parameters need to go into alarm at which point in time. Do note that alarm templates, you can have various different alarm templates next to each other, and you can have a group of elements in your system that are using, for instance, template A, and another group of elements are using template B, and maybe even over time change that easily. So it's not necessarily one template that is active across all your elements. You could have like 5 different templates active on various different elements. What I do want to mention also is that we have an example here of a Cisco manager, but we have a parameter here, and we are able to provide you already with some default values as well in here. The driver basically contains always the no monitoring, what we call. That's a default template that is in there. The no monitoring, because none of the parameters will be activated for monitoring, but it allows you to start from there and immediately enable this parameter and already have some thresholds available that we provided to you within the driver. Okay, so we will be working in the protocols and templates app as we have been doing already for the protocols module. In the protocols module, we were focused on the first 2 columns. Now we will be focused on the alarm section here. Let me immediately show you in our system. So let's go to our DCP DMA, and in here, let's go to the apps. And in the apps, go to the protocols and templates. So before we saw how to add a new driver, we have a list of drivers available or protocols available here. And on the lower right-hand side, I can go for upload and select, for instance, a driver from my desktop to add it in here. Let's just go back maybe to Microsoft. You can actually type in there to immediately go to Microsoft. I typed MI and it jumps to the Microsoft platform. In meantime, I actually added a newer version. We were running on the 11085 before. I've added the 1135 just now and also set it into production. By the way, I did not mention it previously, but this icon here represents that this version is signed by Skyline, so there has no changes been made to this driver, while the previous driver was probably still modified here on the system. So if I would open up this driver, make a change, even one letter to the driver, I would break the signature and it would no longer be signed by Skyline. So I'm now running on a signed version, and it's the production that I'm using. Be aware, if you're selecting your version, you can create alarm templates. So we will be focused here on creating alarm templates. You can create that for a specific version. As mentioned before, always use production version. So typically I'm always using production version and all my elements are using production version. So also the alarm templates, I would basically create them for the production version and not for one specific version in that list here. So that being said, we will be focused here on the alarms. We will create new alarm templates. We will assign it to the elements. We will take a closer look at opening the alarm templates to do the configuration in there of all my alarming and monitoring that I want to activate and configure in there. And then we will also make a alarm template group. So let's immediately dive into it, I would say. We will start with creating a brand new alarm template. So how can we do that? You basically right click on any of the alarm templates in that section here. You will have at the minimum have the no monitoring in there because that comes by default with the driver. You can right click on there and add a new one in there. If you created one, you can right-click, open it, new card, etc. You can also duplicate an existing one from the right-click menu and, of course, delete it as well. I will go for the new, and then it brings me to the pop-up. For now, we're just going to go for a regular alarm template, not an alarm template group. We'll come back to that later on. I give it a name, so use a meaningful name, of course, and the protocol and version, you don't need to touch that because I'm inside this specific version that I want to work, the production version of my Microsoft platform. So let's immediately do that. Let's just right-click. Note if you right-click on a standard, the standard, which is an existing alarm template, you can also duplicate it and delete it. If I right-click on the no monitoring, I can just do a new. So I just go for new and I specify my first name, for instance, bird training, just as a test. And I created a brand new alarm template and it immediately opens up. So I see the name here, it's for the Microsoft platform, the production, and the version that is currently in production is also indicated. And it basically gives me a list of all the parameters that are available in that driver. So let's take a look on how that configuration works of the alarm templates. First of all, I mention all the parameters, but actually that's not completely true because in a driver, we can define whether a parameter is interesting, is useful for monitoring. So we have a lot of parameters in a driver, but we only display a subset of the parameters in the alarm templates, only the ones that are meaningful for the alarming or the monitoring. If you have, for instance, like a device name, or if you have the date time coming back from a device, those are things you typically don't activate for monitoring. So we will leave those out. If you would be missing a parameter, let us know. If there are way too many parameters in there, let us know as well. We can make sure that you have a good overview there. So what will be found in there? As I said, the name of the parameters, but immediately we can already see the checkbox in front of that, and the checkbox in front of that allows you to activate the monitoring yes or no. So I can simply just enable a couple of checkboxes for which parameters that I want to activate monitoring on, and that's done. What else do we have? We have the units, which will be important when we define our thresholds. So if we define thresholds, are we talking about, in this case, percentage, or if we're talking about megabit or kilobit, or if we are talking about dB or dBm. So that's useful to know, of course. And then in the color-coded boxes, you can specify your thresholds. There are a whole bunch of other columns. I will go through all of them. We will just start with the basic ones first. So I have the name of the parameter, the checkboxes, and then I can specify the thresholds in the color-coded boxes whenever I activated the monitoring on there. I will immediately do that in a demo as well. So you just click on one of the cells and it will just give you an edit box where you can type in the thresholds. So the thresholds have been specified here, 50, 60. So as soon as my parameter increases and goes above 50, a warning high will be generated. If it goes above 60, a minor high will be generated, etc. I do note, although, that within that critical high section here, I have 3 numbers. That's kind of strange, you would say, you could think. Well, actually, if you click on it, you can click on the plus sign to just add more edit boxes here and just specify the 80, 90, 100. Why? It's a little bit more a special case, but why can you do that? Well, let's say that my value is continuously increasing. And it reaches, it jumps, for instance, from 48, and the next pulse cycle, it's 52. 52, whoa, we've reached that threshold here. So a warning high alarm will be generated. And the value, you can basically see it in the alarm console. There is a certain value specified here in the alarm. The value that is when the alarm was generated. So if at 52 the alarm is generated, so the alarm will indicate 52, but then if it starts to further increase to 55, 58, the alarm won't be updated because it's only at the generation time of the alarm that the value is being taken. This is not a real-time value you see in the alarm. Of course, whenever it reaches like 62, it will be updated to a minor alarm and it will indicate the 62. If it reaches, let's say 85, it will generate a critical update with 85 in there, but 88 won't update. Well, and actually if it will cross again the 90 barrier and for instance jump to 93, then it will update again the alarm and show in the critical alarm no longer the 85 we initially had, but the 93. So I can show you some demos on this as well. You just click on the cells, you specify your thresholds or potentially multiple thresholds. If we are talking about a discrete parameter, you will have a drop down with all the possible values. So if that's like an on-off or like a signal locked, not locked, these kind of things will be displayed in a drop down. And you select all the possible values that you find in this case normal, or you click on the warning and you specify the ones that should have the warning severity level associated with that. The hybrid parameters, that's the combination between an analog and a discrete, and that's also here indicated. The not available, that's a special exceptional case on top of the number that we have here. So the not available can also be assigned to one of the different severity zones. Okay, I would say let's play around with that and configure our alarm template that we just created. So I just created a brand new alarm template for the Microsoft Platform Production, and I gave it the name BERT Training, and I can immediately start activating my different parameters that I want to activate for monitoring. So you can just enable the checkboxes and immediately you see that the color-coded boxes are becoming available. If I go for CPU load, for instance, you will see that you nicely already have some pre-populated values to give you a jump start, and you can, of course, further fine-tune it and also add 60 in there, for instance, for the miner. The total handles, I will not activate all of them or just specify some values. I'm not really sure the total handles, how many we have, but let's just say 10,000 is my threshold for both of them. We'll see if that generates a warning or not. Note the normal value. You can specify also a normal expected value if you would like to do so. Okay, I just activated a couple of analog parameters now with numbers, and I can specify the values there. Let me scroll down and maybe go to the network adapter and the status of my network adapter. And you can actually see here, it already comes with some default values again. The connected and authentication succeeded is a normal situation. This one disconnecting, authenticating is warning, and the other one you can just go through them. You could say like, okay, I'm not really happy with, for instance, those ones added in here. You can disable it in here, or maybe all of them. Let's say I'm not going to use this one, and you can just activate them in the warning, or let's say that I'm just going to go for warning or normal. The normal is the connected, and all the other stuff is basically the warning. Note there is no distinction between low and high, because we are talking here about a discrete parameter, so there is no low or high. That's just a warning or no warning, no distinction between high or low. Okay, so I activated that my network adapters of my network interface cards, they need to be connected, then everything is okay. All the other things is a warning alarm. Okay, let's say that we are happy with the first configuration we have here. So let me okay this, and it immediately asks me if I want to assign this already to an element. I'm not going to do that for now, because, or I will press no, because assigning through this interface, we will take a closer look at that. But we already added an element to the DataMiner system. Let's go back here, the training Microsoft elements we added with the wizards. And if you remember well, we were able to actually in the wizard define an alarm template. So if I go back to the editing of the elements, by right-clicking on the element and going to the edit here, it will open up again that wizard where I configured everything of my elements. And in here I have the alarm template, which is currently on no monitoring, and I can just select my BERT training that I just created a second ago. Let me do that and apply it to verify the result. So let's open it in a new card maybe, so I can easily switch back and forwards. So I can see that my CPU load is now nicely configured with the 50, 60, 80, 90, 100 threshold. Well, 100 is not a threshold, that's just the maximum from 0 to 100. And also my total handles, well, I said 10,000, it's a lot more than 10,000. And the total processes, that's a lot less than the 10,000 that I specified. So this one is green and this one is a warning. And also the network interfaces have here something like one network card and it is connected. Tables is a little bit more a special case, but I'll come back to that later on. Okay, so that's how simple it is. I just simply went to the Microsoft platform here. Let me go back to the Microsoft platform, went into the production, I right-clicked new, I created this BERT training, and I specified a couple of checkboxes, specified a couple of thresholds, and assigned it to my element, and that's it. That's how simple a basic alarm template works. Maybe you notice that when I open up this existing alarm template, that all of my parameters are gone and only the ones that are monitored are being shown. Indeed, that's if you open it up, an existing alarm template, to have a quick overview of what is effectively being monitored in here. So I can quickly see 4 parameters are being monitored. I can immediately see the thresholds. I have in one blink of an eye a quick overview. But what if I want to add another parameter? Well, maybe you recognize this button as we already saw with the information templates. By default, if you open up an existing template, it's only showing the ones that are modified, the monitored parameters in this case. You can click on there and you can go back to the protocol parameters, showing again all the parameters from the protocol. All the parameters with protocol and general. The general I can show you, that's just a bunch of these generic parameters that are available. That are not specific for the protocol, but are more DataMiner specific, like the log owner, log status, timer base, all these kind of generic parameters. So not something we need to worry about. So I can switch back to the only the protocol parameters. Okay, so if I want to further change it, you can change it. Simply click on any of the values there, change it, save it, and it will immediately be applied again. Now, to show you that multiple value possibility here, I will use another device here. Let me open up this IRD in a new card. And let's take a look at the this parameter, for instance, or yeah, I can go for output gain. If I want to tweak this one, that's an interesting shortcut. If you want to quickly go to the alarm template of a specific element, you right-click on the element, you go to the Protocols and Templates menu, and there you can immediately view the alarm template that is currently assigned to this element. If I do that, it opens up immediately the alarm template and my output gain. And let's just play around with this a little bit so that I make, for instance, 0 the default value. And let me remove this one, remove this one, remove this one. Let me close my surveyor here. And let's, in here now, specify different thresholds. Let me say that starting from 9, I want a critical alarm. And I can just click on the plus sign to add another one. And for instance, say starting from, let's say, 18, I want to generate an updated alarm. Let's see what the result is. If I OK this, and maybe I'll need to open up my alarm console now as well, so that we see the alarm that I will generate on here. In here, you don't see, let me just go for 0. You don't see those different thresholds. You only see that starting from 9, which I specified in there, is a critical alarm. So whenever I go, for instance, for that 9, a critical alarm will pop up in here if I sort on time. So I have my 9 IRD2. 9 alarm that is being generated here. If I go a little bit higher to 12, my alarm is still indicating 9. So if I go for 15, it is still indicating 9. But I also specified the 18 as a separate threshold in the critical, and then you will see that the 9 is effectively being updated, oh, here it is, to 18. So the existing alarm, they are 2 critical alarms. First it was 9 and then it was updated to 18. So you can achieve that by specifying that second threshold as we seen here. So that's the reason why you can add several thresholds into one severity field. Okay, so that was the basic alarm template. You activate the checkboxes on the parameters you want monitoring, you specify the thresholds, and that's how simple it is. Now in the right-click menu, you will be able to do some bulk enabling. So you can just select a bunch of parameters and enable all of them for monitoring or disable them. The inclusion, exclusion, that's something we will see later on with alarm template groups. For alarm template groups, it is important to include or exclude the parameters. Duplicating, we'll come back to that for the table. And you can also export it here to a CSV, more for debugging or documentation purposes. Maybe you already noticed that there is a possibility that a validation is happening there. So if I go to my alarm templates and I specify something which is, for instance, out of range, it will say the CPU load has limits that are out of range. Or if I would specify something which is, again, lower, let's say 40, it will say like, okay, it has invalid limits. So it states it up here and also while you are typing here. So let me put it back to 90. So this makes sure that you cannot make any mistakes. So you cannot save an invalid alarm template. So we do some validation there. Now, let's go for a little bit more the special cases now. The first one I want to mention here is the matrix. The matrix does not really fit into the editor, so it comes along with a matrix parameter, including basically all the inputs and outputs. This is a 10 by 2. It basically gives you a button there that opens up the matrix level editor in a separate window. And there you can define the alarming on all the inputs and output cross points. So all the cross points, you can define an alarm level to it, but also the inputs and outputs itself. Basically, you could say that if a certain input is not connected to something, I want to generate an alarm. So that's not a cross point, but that's actually if there is no cross point, I want to generate an alarm. I can show you a quick example on our demo system. If I take a quick look, we do have over here an SDI matrix, for instance, and let's open up. So the shortcut, you just right click on the element, view underneath protocols and templates. You can view the alarm template of this SDI matrix. The matrix parameter is not in here. That's because it's currently not being monitored. So I need to click on the showing the protocol parameters there. Now it's there. So I have my matrix. I can activate it for monitoring, and I need to click on this button to basically open up a bigger editor so that I can see all the inputs and all the outputs. And I can just select one of the cross points. I just click on it. Now this one is selected and highlighted. And I can say this was normal, and I can do also a click and drag to select all the other ones and say this is warning. So it's expected to be on output 1, all the others will generate a warning alarm. You can also click and drag down to put, for instance, everything green and just have whole sections being activated on a certain alarm level. Don't worry about information events. I'll come back to information events later on. But what if the input is not connected to any output? I cannot select any of the cross points here because it basically means no cross points. Well, therefore, you need to go to the input-output selection mode. And now I can select this little dot, you could say, and put, for instance, a critical alarm on there. So whenever the input 1 would not be connected to any output, it would generate a critical alarm. So you can, of course, do that on the outputs as well. And for instance, say that output, oops, that was not the intention there. These ones are normal. I would need to go to the output selection and put this one on critical, for instance. Okay. So that's how you can define the alarming on all the cross points and the inputs and outputs there as well. To show you the results also here, that's in the viewing modes. So the cross points have monitoring, and in this case, the input 4 is not connected to any output, so it generates a critical alarm. In this case, the input is connected to an output, so it is okay, and it is in a normal state. And of course, the other ones are just color-coded with the background. A very important one that I want to definitely spend some time on now is tables. We do have a lot of tables in DataMiner. A lot of information is coming back from a data source in tables. I'll use the task manager as also indicated here, but you could have a list of, but also network interfaces or hard disks or these kind of things, or like a number of items that will be in a table. But it could be the ports on a switch. It could be services in a transport stream or bits, all kinds of tables we will find in DataMiner systems. How is the alarming working there? Well, we already saw it a little bit on the network interfaces that I enabled just a second ago or a minute ago, but I'll do it again here on the task manager. What we will see is in the alarm template, which is indicated here on top, in the alarm template, we will find for the task manager, the table that we are looking at. For that table, we will find all the columns. So every column we make available, like the name or the bit won't be in here because it's not useful to activate monitoring on there. But the ones that are useful for monitoring, you will find them back in the alarm templates. So in this case, we have the task manager with the CPU load here on the processes, and we can activate this checkbox and the whole column will be activated for monitoring. Let's maybe do that already. I'll immediately come back to the filtering here. So let's go back to my DCP DMA. I still have my alarm template open and I still have my Microsoft server next to it. So we already activated the monitoring on the CPU load and the total handles and the total processes. Let's take a look at that task manager. So I'll go to the task manager, and what we will see is you have all the processes in here. Note, if your task manager is empty, you need to make sure that the polling of the task manager is enabled. If this is disabled, your task manager is empty and we are not doing any retrieval of the task manager data. So you can actually disable that over here. I can show you, then the list basically becomes empty. If you enable it, we start the polling on there. So let's now take a look at my alarm template, and let's see, basically we have in the alarm template all the parameters nicely organized per page. So we have the performance page and we have the task manager page and the service list. So let's take a look at the task manager, and I do see for my task manager table a whole bunch of columns that are available in here. So let's activate the task manager CPU here. And let's say that I'm expecting like 0% or 1%, doesn't really matter. And say like, okay, I generate a minor alarm as soon as one process goes above 15%. Okay, let's just apply that or okay that. And I closed it by clicking OK. I should have clicked apply. And you can immediately see that all the CPU cells here are being monitored with the green backgrounds. Note there is a little bit of an indication in the how intense the green is or how dark the green is. That's just to give a visual indication of how high the number is. It has nothing to do with the alarming. It's all green. It doesn't make any difference. It's just to have a visual indication of where the highest numbers are. Okay, that's all perfectly fine. I'm now monitoring all the CPU loads on my server of all the different processes on there. But honestly, I'm not interested in a whole bunch of these processes. I'm only interested in the processes doing the job here on this server. So I want to have a subset of processes. And I can do so by using this filter that is right behind there. This filter allows you to specify a simple mask. The mask can include a star basically meaning 0, 1 or more characters, or a question mark. A question mark is exactly 1 character. So in this case, it specifies SL star, meaning that all the processes starting with SL, will match this filter, and it will effectively narrow down that list of monitored cells to all the SL processes. Okay, let's take a look at that, and let's open up my training BERT again by double clicking on there. Notice again that of course only the parameters that are activated for monitoring are in here, because that's the default how it opens. You can switch back if you want to add more of them. What I will do is, you can see the star here. I will specify SL star. So by default, it's star. By default, it's every entry in the task manager table. I'm only going to go for SL, and I'm going to click apply now so that it doesn't close, and verify the result. You can already see they are all back to the gray backgrounds. And starting from SL Analytics here, you have the green background, and you have all the processes starting with SL being monitored. And it stops here at the next one, the SM process. So that's how you can narrow it down to only a certain number of processes or any kind of entry. Do note it is on the name, so it's on this column indicated by this icon as well. So this one is where the filtering happens. But I do also want to filter on or do monitoring on some other processes, because maybe I want to also activate the monitoring on Elastic or Cassandra or something. Well, therefore, you actually are able to click on the plus sign to duplicate that line. So you can also right click on the parameter and choose to duplicate that line. So here the duplication of lines is applicable. And basically we can just add more filters and say like, I want to activate, for instance, let's say I want to activate also the monitoring, let's say on the Cassandra here. So I need to activate I need to click on the plus sign, and now I have 2 times the SL, but of course I want something else. So I want to have it on the prun serve, that is the Cassandra that I have there. So, and I also will add the star to make sure that it matches there. If I apply that, you will have also now the green background on the Cassandra service process in here. Now, if I move my mouse over the lines, you will actually see that there is some kind of like arrow up and down, and you can also remove it again. Because if I actually have something like, let's say SL, or let's take the analytics. If I do something like this, note that the casing does not really matter. If I do something like this, well, actually, I will never, let's say that the analytics needs a little bit more CPU load or less. For instance, I allow it only 5% and I want to generate an alarm. Well, actually, it won't use this for the analytics because it goes top to bottom. So whenever a process, we need to define the thresholds, SL Analytics comes in. Will it match the SL star? Yes. So we will use the first line, and that's the thresholds we will use. So we should actually move it on top. If analytics comes in, it matches here, yes. So we will use the 5% as the thresholds. If another process comes in, like the SL log or SL element or SL DataMiner, it won't match the first line. It will go to the next line. This will match, and it will use the 15. If nothing matches, of course, no alarming is being generated. So just to show you that this works, what I will do is I will disable the monitoring on the SL Analytics, and I will apply that, and we will verify the result. And now you should see indeed here that the SL Analytics is actually not being monitored. So the first one is no monitoring, because I said that it didn't need to be activated on this process. Okay, so for tables, it is very important to keep in mind that you are activating monitoring on a complete column. So be aware of that filter if you only want to do it on certain entries in that table. And you can duplicate those items to have several filters, and make sure that your order is correct if you do some filterings that are overlapping. Of course, in my case, my first case, the print server and the SL star was completely separate, so it doesn't really matter the order. But if the filters are overlapping, make sure that your narrowest filter is on top. Okay, very important, the filtering and the alarming on dynamic tables. Now, what else do we have available in the different columns? So what we will do is we will basically take a look at all the different other columns that are available in here. So the first one that I will discover now is the info column. The info column here, something you notice already, there is another checkbox. And if you enable that checkbox, you can specify again there a value, like for instance, let's say 50 again. So a little bit similar as a warning, you could say. But what is that info that I can activate? Well, basically, instead of generating a real alarm, like a warning, minor, major, critical, that starts worrying people that are arriving in the alarm console and starts the color coding in the tree and things like that, you can actually generate an information event. And as you can see here in this screenshot, it will generate an information event that in this case, the total processor load escalated above 10. So we specified here a 10, and each time the total processor load in this case goes above that 10 threshold, it will say escalated above 10. And if it drops again across that threshold there, it will say dropped below 10. So each time it goes above or below it, it will generate an information event. And this information event is just something that is being generated. Nobody is worrying about it. It is tracked, although I can still go back in there and verify if that was effectively changing. So maybe if you want to track something like a fan status on off, you can actually generate an alarm, an information event on there instead of an alarm. We can, of course, also activate trending. That's something we will discover in the trend templates. But why it is also useful is that I can actually generate or trigger a correlation rule based on an information event. So if I want to trigger a correlation rule whenever my CPU load goes above 10%, but I don't want to generate an alarm, well, I need to generate then an information event, because correlation rules only trigger on alarms. There needs to be some kind of trigger. It will never verify a real-time value and track it continuously. You need to have some kind of trigger. This can be a trigger of a correlation rule. So you can activate it on, like in this case, the total processor load whenever it goes above or below the threshold that we defined. You can actually also define multiple thresholds by clicking on the plus sign, or you have the exceptional value here. And of course, you can also do it for discrete parameters, like I mentioned, like a fan status on off. You can also activate the generation of information events on these parameters. Do note that you can do that separately. So you can just say, like, I'm not going to activate the monitoring on the CPU load. I'm only going to activate the information events. So those are two separate things you can activate. You can activate one or the other or both. So that's how it works. Okay, I can quickly show you an example. I'm going to do that on my IRD, because this one I can easily tweak, you could say. The parameter I can change, I meant. So let's open up the alarm template for this one. And the output gain that I just configured before, where I specified the 9 and the 18, let's also activate one which says 12. So I'm also going to activate an information event whenever 12 is being crossed, going up or going down. So let's verify the results and let's open up the information events. And of course, everything in a DataMiner system is being tracked. So also my set will be tracked. So you will see that a set has been done here by Bert Vandenberger to 9 dBm. And it did cross, but let me check. It did not generate the alarm yet. To 15. Oh, there it is. Escalated above 12 dBm is now being generated there. So each time you cross that boundary, that trigger is being generated, and you can take some actions on there, send an email, execute a automation script, things like that. Okay, that's the information column that we have available in the alarm template. Probably more interesting and more frequently used is the hysteresis. So we do find, let me pop up the alarm templates of my Microsoft elements. So now we are focused on those two columns that are right next to the critical high. So the hysteresis on and hysteresis off that is available here. I already explained you in the DMS introduction, a hysteresis is basically a delay on the alarm generation or the alarm clearing. Basically, I can just specify there simply a number of seconds. A number of seconds that the DataMiner system must wait before effectively generating the alarm. Let's say that the alarm starts, or the signal level here starts to increase and it goes above my threshold. Immediately, in this case, the alarm is being generated and a critical alarm exists in the system. Maybe my value goes a little bit below my threshold again. So actually it's good again, but DataMiner, we specified like, oh, you have to make sure that it's stays good for a longer period of time before we take away the alarm. So we have, for instance, specified 30 seconds, and it was actually only a few seconds, like maybe a couple of seconds, 5 seconds underneath that value, and indeed it went back to a bad value. So sometimes you could have a value that toggles between like just below and above the threshold, and it's sometimes a little bit above and below, and to avoid that the system is continuously saying like alarm, no alarm, you can define a hysteresis on there. So the alarm stays in the system because it was not good for a longer period of time. It goes again for a good value, and now it remains good. And then we say like after 30 seconds, for instance, we take away the alarm, and now we are sure that we are in a good situation again and everything is back okay. But this is a clear hysteresis or off hysteresis that we defined in here. That's, for instance, for a signal level, because if the signal level goes bad, we immediately pick up on the problem. But if we would talk, for instance, about a CPU load, the total processor load of my Microsoft server, it's perfectly normal that it goes to maybe 90-100% for a moment in time, maybe 5, 10, maybe even 20 seconds, because it has the CPU power. It should be able to use it to the fullest extent. So I'm not worried that the CPU load goes sky high for a moment in time. So I don't want to generate an alarm immediately. I want DataMiner to wait maybe even a minute or 2 minutes before generating the alarm. So you could say in the on hysteresis, like in this case, we said like 60 seconds. You need to wait 60 seconds. So if it goes into an alarm zone and it's there for a few seconds and it goes back, no problem. Somebody applied some configuration. It was using some CPU power to take that into account. That's a perfectly normal situation. But if it stays there and it keeps on staying there, and it's still there after 60 seconds, then I want to generate an alarm. So that's a delay on the on-hysteresis, the alarm generation that we can specify. Do note that you also have the possibility to define for which severity zones that you want to activate that hysteresis. By default, it's on all, but you could say, for instance, that only for, in this case, for instance, critical and major alarms, the hysteresis is taken into account. So I only generate a critical alarm when I'm really sure that it wasn't just having a quick spike to the critical zone. That's a very powerful feature, the hysteresis, to avoid false alarms and an overload of alarms. So definitely make sure you use it to the fullest extent. We are not able to play with the CPU load easily, so we will go back to the Philips device that we have here with the audio output gain and open up once more that alarm template that we have there. So I right click on that device and I say protocols and templates, view alarm template once more. Maybe I just close those ones for now so that I can have them next to each other. So I'll put the alarm templates on the left. So let me activate some hysteresis on there on the audio output gain again. So I won't go for the info. Let's say I generate let's say that I want to immediately pick up on the problem. So the on hysteresis, I leave it blank. That's basically immediately generating the alarm. But if it goes back normal, I want to make sure that it's normal for a longer period of time. And only after 5 seconds, I will effectively clear the alarm there. So it's also indicated in the UI that this is now applicable, the clear hysteresis. Let me first go back to a normal situation, which is something like 3, for instance, and open up, or let me maybe open up the active alarms linked to this card so that we only see the alarms of this device. So if I generate an alarm, it will immediately pop up. Indeed, the alarm is already there. If I clear or if I have, like, for instance, a small drop back to the normal and then immediately back to the critical, you can see nothing happens. So if it toggles a couple of times to a normal value again, nothing happens in the DataMiner system because I defined in here an off hysteresis, the delay on the off on the clear. So the clear is being delayed. So only if I go back to a normal value, 1, 2, and I wait for 5 seconds, then my alarm disappears in the DataMiner system. So there was a 5-second delay before DataMiner was effectively removing the alarm. So that's also sometimes a little bit confusing, if you take a look at this and you say, okay, if the time would be something like 60 seconds, so it could be a little bit longer period of time as well, of course. You do have a normal value again, for instance, like 3. You could be confused, You could see like, oh, this device is in alarm. You go to the device and you see like, oh yeah, the alarm is there, but why is this in alarm now? It's a normal value. Well, maybe you have to wait a little bit until the hysteresis is over and the 60 seconds is gone before the alarm will effectively be taken away. So be aware of that confusing view you might see there. But as I said, the hysteresis, a very important feature to avoid alarm toggling, to avoid excessive amount of alarms. Remember, for something like a signal level, you immediately want to pick up on the alarm, but the clearing can maybe be delayed, the off hysteresis. For something like a CPU load, you will use the on hysteresis. You won't generate continuously alarms with some spikes now and then, but if it stays there for a longer period of time, then you want to have an alarm. That's the on hysteresis, the delay on the alarm generation. Okay, remember about that hysteresis, it might come in handy later on. Okay, normalization. Let's take a look at normalization of alarms. What is that actually? Well, normalization of alarms allow you to make sure that an alarm template can be reused among different elements in your DataMiner system. If I have 10 different servers, they might all have a different CPU load and different circumstances. The memory usage might be different. If I have satellite receivers, the signal level might be different. I might have parameters that are depending on circumstances, the signal coming in or the bandwidth that is going through the system. There are variables. So sometimes it's difficult to define fixed alarm thresholds. Let's just assume, for instance, the total processor load. If I want to configure a normal value and what is a high value, well, this one server could maybe be already like, I want them to generate an alarm if it's above 50%, while the other one is maybe all the time on 50%, and I only want to generate an alarm when it's above 80%. So how can I do that? Well, you can, of course, duplicate your alarm templates. And you can have an alarm template with high thresholds and with lower thresholds. So that's a valid approach. But sometimes over time, you might have too many alarm templates because sometimes they might have all different values. And there, denormalization might help you out. What basically happens is if you, the normalization, let me show you maybe first in the UI. So if I have my parameters in here, you do see the type of thresholds that I define. By default, they are normal. So the normal thresholds, and I can just specify fixed thresholds. If I move that to relative or absolute or rate, I'll come back to those. Let me also maybe remove that 60 again, that we are not bothered about that one. As soon as I go from normal to relative, you see that the normal value is replaced with the baseline. And if I specify something over here, it says delta 3%. So basically, I no longer specify a fixed value in the warning or any of the severity fields, but I specify a delta, a difference with a baseline. And what is the baseline? What is the normal expected value? Well, the normal expected value will be different for each and every device or element I have in my DataMiner system. So my element A and my element B might have a different normal value. And I only specify if the normal value increases with 3%, like I have in my view here. If it increases with 3%, then I generate an alarm. So basically, an absolute or relative alarm template allow you to specify a deviation from a normal expected value. So there are two ways of defining it: absolute, relative, and rate is a special case. The relative is in percentage deviation from the baseline, but I'll go for the absolute. That is basically in dBm. And if it's 3 dBm more than the normal value, I generate a warning. And if it's, for instance, 6 more, then it's a major. And I can go for the same thing at the lower hand side as well, for instance. So if it's 3 more or less than the baseline, it's a warning. If it's 6 more or less, it's a major alarm. Okay, so you specify a deviation from a normal expected value. But now how can I define that baseline? Simply by clicking on it. If I click on it, it will open up and it will show me all my elements in my DataMiner system that are using this template, this specific template that I'm editing here. And I can immediately see that the current value is specified here. My IRD2 I was working on before, and I can specify a baseline value here, and I can specify, for instance, okay, this is indeed 3. So for IRD2, that's the 3 is the normal value. If I close that, if I apply that, let me show you the result for a second. So 3 is the normal value, for this IRD2. I do also have an IRD1. Let me open up this one in a new card. This one is also using the output gain or the same alarm template. For one or another reason, it is currently being masked. So let me unmask it so that we see the alarming. It has no thresholds. Why does it not have any thresholds? Well, let me go back to the alarm template. If I clicked on the baseline, I specified a normal expected value for IRD1, but not for IRD2. So I need to specify a value there as well. So I need to specify over here, for instance, let's say 18, the current value, not to generate any alarms. Let me close that, apply that, and let me go back. And now I see that this one is indeed 18. That is being the normal value with 3 dB less, dBm less, and again 6 dBm less than the normal value generates a major alarm. The higher one already goes above my limit there. Now, so let's recap that. So we do have next to the normal value, the normal thresholds, where you define fixed thresholds for all your elements, the possibility to go for relative or absolute, relative in percentage and absolute in real values, a deviation from a normal expected value, and the normal expected value, you define that for every single element you have in your DataMiner system that is using this alarm template. So this allows me to have one alarm template that I have here, and I have two devices using it. Let me put them next to each other. So I have two devices using them, and they are both using the same alarm template, and still my thresholds are actually changed a little bit because the one device and the other device is in different circumstances. Now, the rate alarm. What is the rate alarm? That's a special case. I can activate it, the rate alarm on there. It's not so visible, but it indicates rate here. I can no longer click it. Why is it? Well, actually the normal expected value here will be the last or the previously polled value. The previously polled value. Yes, the previously polled value. Let me show you. So currently it's still 3. That's still 3. Okay, that's perfectly fine. What happens if I increase to 6? I will actually generate a warning alarm. Okay, it's a warning alarm. And the next poll cycle, it jumps back and the normal value expects 6 now. And if I do a bigger jump, it will generate a bigger alarm and it will jump back to normal. So it's when the rate of how fast this parameter is changing is going too fast, it is going to generate an alarm. So a small change is accepted, a bigger change is not accepted. Maybe I should have removed the warning alarm, so you can ignore the warning alarm. This is not, of course, interesting on this parameter, but that's could be interesting, for instance, on errors detected. So a number which is continuously increasing, you could say like, okay, a smaller jump is allowed, a few errors are acceptable, but if all of a sudden a big jump is happening, then I want to generate an alarm. But be aware that a rate alarm is by nature an alarm that will automatically disappear. It will be generated, but the next poll cycle, it will be expected to be normal again. Well, if I have a stable value, unless it continuously makes big jumps, then the alarm will, of course, remain there. So a small jump now and then, a new error that is appearing and that number increases, that's fine. But suddenly a big jump, we will generate an alarm, and if it then remains stable again or more or less stable, then the alarm will disappear. But you can pick it up with correlation, of course, to make it a persistent alarm. So that's the special case of the rate alarm. Basically, the baseline is following you in time and is using the previously polled value. Note that in my case, let me open up the alarm template once more. In my case, I was actually using before, let me go back to the absolute ones that we are back to the normal. You could have seen that here, because my value, my normal value of this one is actually quite high, it's 18, that my warning and my major alarm is actually out of range already. If you want to avoid that, I can actually even say that even if my IRT2, let's say if it's 15, even then I will only have my warning in there, but my major is still out of the screen. You can actually avoid that by saying like, okay, the warning or the major high here, yeah, 6 more than the baseline, yeah, that's all fine. But I actually say that there is a fixed, or let me add another one, a fixed one of, let's say 18 then. Or not fixed, let's just go for 18, fixed. If I enable that checkbox fixed, it will say like at any time, doesn't matter what the baseline is, 18 is a major high. So now it doesn't matter that my normal value is 15 and this should be warning. I actually say 18 at all times is my cap there. That's a fixed threshold. So in this case, it's also here now fixed on 18. So you can actually combine the delta specifications with also a fixed threshold. That's just a small side note. Now to talk a little bit more about that baseline. So if I clicked on that baseline, I was able to specify the normal expected value for my first and my second IRD. Okay, but let's take a closer look at that. Actually, in this case, you can already see that you can also have it activated on tables. So in this case, it's for one specific element for different processes. So also inside a table, this can of course be applicable. But note that baseline editor, what I did is I said like, okay, click on the baseline, and I clicked on it and I specified a value. Well, you are actually able to take the current value, like here we have the current value is 12, and you can also say use the current value as the baseline value. So you can just do a multiple selection of all of your equipment, or the ones that have a value at least, and say like, okay, now everything is fine. All the signal is fine and my operations are okay. So I will take the current value as like a snapshot, you could say, and move all of those current values immediately to the baseline. So you can just do a multiple selection, say use the current value as the baseline, and what will happen? It will copy that in there, and now the current value will be applied again on this one, which was 18. So that's a quick trick, you could say, to easily copy, take a snapshot of your current system and move that into the baseline. Next thing I want to mention is below there, you do have some automatic updating of your baseline that is possible. So there are actually two ways of allowing DataMiner to automatically take care of deciding what the normal expected value is. First of all, you need to have trending activated on that parameter before you will be able to do so, because what will basically happen is that DataMiner will take a look at the trend history, the trending of the last couple of days or week, depending on how you configure it. And based on that history, it will do the configuration of your baseline, your normal expected value. You can do it in two ways. If you activate this automatically update of baselines, you can first of all go for the detection of a continuous degradation. Basically, it means that this is what I expect more like to be a constant value. It's a certain level of a signal coming in, so it's more or less a continuous specific value that I expect. But of course, I have a lot of these receivers and a lot of different signals. Some of them are a little bit better than the other ones, so they have all different kind of levels. So instead of manually maintaining that, you could say like, oh, DataMiner, what you do is you go and take a look at the trend window of the last 7 days. You take a look at the last week. You take the average, well, more or less, and you say like, okay, that's what I expect. And if suddenly the signal goes a lot higher or a lot lower, I will define if it's plus 3 dBm or minus 3 or 6, doesn't really matter. I will generate the alarm. So you specify the delta in your alarm threshold. That's the only thing you have to specify, the delta on top of that baseline, and DataMiner will calculate the baseline based on the last 7 days. Now I set average. Technically speaking, it's the median value. We take the median instead of the average because the median will make sure that big spikes, if you suddenly have a drop or an outage somewhere, that it doesn't influence the average that fast. So therefore we go for the median value. It will take it from the last 7 days. You optionally can skip the last 24 hours or last X hours, so that if all of a sudden the signal starts to deviate and it starts to slowly degrade, that you would still be able to pick up on that by removing the last 24 hours, for instance. Now, this is more for a static value, or what we expect to be more or less a stable value. But we do have a second option here, that is for the daily pattern. Because sometimes we have parameters that are having a daily pattern with day-night behavior, human beings getting up in the morning, doing all kinds of activity, network traffic that is being generated, and going to bed again in the evening. So you could have like ups and downs in certain trend graphs or certain parameters. If you want to activate monitoring on that, you sometimes might have difficulties by defining a minimum and maximum. Let me show you an example on the demo system we have here, and let me search for the Leo device here, which should give us some parameter that goes up and down in a daily night behavior. Week to date. So you can see every day of the week it goes up and down and up and down. So, but if we want to make sure that we pick up on certain outages, note this is the cable modems offline. So a lot of them offline is not so good. You might have an outage. Of course, overnight they go to bed, and in the morning they get up again, and some people are turning off their cable modem. So the day-night behavior is not a problem. But if suddenly you might see an increase like this, there might be a problem. But how can you pick up on that? If you need to use regular alarm thresholds, you would need to go for something like, okay, my thresholds start at even here 25. It is even too soon, you could say, because here we have regular behavior which is already going into the alarm zone. So even the 25 is a bad configuration here. So we really need to set it very high and lower thresholds very low to have the whole curve matching in my normal zone. So how can I fix that? Well, you can actually say I'm going to go for that daily pattern. And what DataMiner will do is DataMiner will take the day and it will slice it up into 15-minute slices. And it won't just take the average of the last full 7 days, but it will take the average, or the median, I should say, of the 15-minute time slot now and a day ago and 2 days ago and 3 days ago, then until the 7 days, and define the average or median value on that. So whenever we look at a specific time, DataMiner will take that time and go back to the previous times and take the average from this one and this one and this one from all the previous days and define like, okay, that's the normal expected value at this point in time at, for instance, 8 o'clock in the morning. And it does that for every 15-minute slices or time slots, you could say. So every 15 minutes, DataMiner will again update the new baseline and slowly move the baseline or normal expected value lower and higher as the day moves along. And of course, then the great possibility we have there is to define a threshold that says like, oh, if I'm, let's say, like 2 or 3% above the normal expected value, then I generate an alarm in DataMiner. So that would allow me to say like the normal expected value, I expect it to be something like 15 in here, but I can say if it's 3 more, 18, it would effectively pick up on this alarm at this point in time. If it's an hour later or a few hours later, 18 is a normal value, but not at that point in time. So that's how we can pick up on a problem automatically by changing our baseline over time. So you can say follow the daily pattern, and DataMiner will each 15 minutes change your normal value, and you can nicely have your alarm thresholds move along with the expected behavior of that parameter. Again, we can specify the 7 days with the skipping of the last 24 hours. We have the possibility to do so. And we can also, in this case, handle weekend days separately, because if human beings are involved, the weekend days might behave a little bit different. Okay, so remember that normalization, the normalization allows you to reuse an alarm template more broadly than a regular fixed alarm template, because if you're just going for the fixed thresholds, you might say something like, oh, let's duplicate it and have a little bit different thresholds for this device. No, think about leveraging that absolute or relative thresholds, so that you can reuse the same alarm template across different elements with a little bit a different normal value. You can specify the normal value yourself by clicking on that baseline and getting to this editor here and specifying the baseline, or you can decide for DataMiner to take care of the calculation of the baseline or normal expected value. And of course, we had that rate alarm as well, which is a special one where the baseline continuously follows us in time, you could say, to allow you to generate an alarm when the jump is too high on certain parameters. Okay, some more advanced settings, you could say, because they are not shown by default. If you click on the cogwheels here, you basically have a couple of things we can show and hide. The first thing is the inclusion-exclusion of the parameters. I'll come back to that in the alarm template grouping. So that's for alarm template grouping. So, but whether to show that extra column, let me show you in our DCP DMA. So if I go back to the DCP DMA, yeah, it is shown here, but by default, it is not shown. There is no column for including or excluding a parameter. That's now shown if you enable this. And you can also do that for the allow overrides. Maybe you didn't see something changing. Well, that's because the column is actually added at the very end, the auto clear. So if I remove it again, you can see there is no auto clear column. I'm at the very right hand side. Oh, let me add it again. What is the auto clear? And let me add it again. What is the auto clear? The auto clear is basically something I mentioned in the introduction, where or in the alarm module, where I said like by default when DataMiner generates an alarm and the alarm disappears again on the element, DataMiner will auto clear the alarm. It will be removed from your alarm console. It's gone. You need to go back into the history to be able to go back to it. So by default, a DataMiner system auto clears alarms. But what you can also do in the DataMiner system, you can change the system default so that all the alarms that DataMiner is generating will, whenever they clear, will remain in my alarm console forever as a clearable alarm, and an operator, somebody needs to go in there and right click on the alarm and say like, yeah, I've seen the alarm, you can remove it now. And now it's clear and now it's gone out of my window. Okay, you can system-wide do it for all the parameters or none, but maybe I want something in between, and that's what you can do here. Let me show you. So I activated that override of the auto clear column. So I now have the column available, and I'll do that on my audio output gain again. But let me go just back to normal thresholds, and let's say that 6 is normal, and let's say that 12 is a critical alarm. Let's just keep it simple so that I can generate some alarms. And will the auto clear is by default, it is true if you did not change your system default. But what I will do is I will, for this single parameter, put it on false. So every alarm that is being generated on this audio output gain on any of the Philips devices that are using my standard alarm template will not clear and will remain in my system forever. Let's apply that and let's generate an alarm. So I have my IRD2, for instance. Let's clear, it will already probably remain as cleared alarm in there. Yes. Do I have a hysteresis? IRD1, IRD2. Let me check again let me make sure that it is using the standard alarm template. I have my standard alarm template. My hysteresis is off. Let me apply that again to make sure that it's... sorry. I do not see all the alarms. There is on this element some other alarms that are probably generated here. Now it's gone. Somebody probably just cleared it. Now you can actually see, it took a second there. Now you can actually see I cleared the alarm, but actually the alarm doesn't disappear from my UI. So it remains in my system forever. And that remains in my system as a clearable alarm, a green alarm. So I can see it's fixed the problem, and the problem no longer exists. But it stays here to make sure, like, watch out, something happened there on the device. If I would generate an alarm on any of the other parameters, let's say I generate here a warning or a minor alarm, and I clear the alarm again. Whenever I clear the alarm, enter a value, sorry, enter a value, clear. Whenever I clear the alarm, bam, it's green, it's gone, it's removed from my alarm console. This one remains here forever because I disabled that auto clear with that special column here. Now an operator can verify the problem and say like, okay, yes, I double checked it, and now you can right click on the alarm and you can clear the alarm, you can add some optional comments, and now it's gone. Now it's taken away from your alarm console. So that's the clearable alarms that you can activate You can activate it system-wide, as I've discussed in the alarm module, but here in an alarm template, you can activate it on a single parameter or maybe a few parameters that are very important that you want somebody to further investigate if ever an alarm happens on it. Even if it's only for 1 single second that the alarm popped up, it will stay there. So remember that that might come in handy. The anomaly detection, that's the AI helping out. So by default, the anomaly is disabled, but you can actually enable it. So it's a simple enable disable. If you want to further have some more information, there's more information on the help, but actually some more details are also, or more configuration, I should say, is available if you activate the advanced configuration of anomaly detection there. And let me scrolling. The anomaly detection. So now I have, instead of 1 button to enable the anomaly detection, I have the 3 buttons, and I can actually see what kind of things it will do. So the first one that I can activate, so if you go for the simple version and you say enable anomaly detection, it will basically activate all 3 of them. So you can actually open it up and say, like, I want to select only 1 or 2. So anomaly detection, if you activate that, all 3 of them will happen. The first thing I see is the trend monitoring that you can enable. That is basically the AI that is going to keep an eye on your parameter and see how the trend evolves. So if it's a parameter that is continuously stable for a considerable amount of time, and suddenly it starts to increase, it will generate an alarm on that. Or the other way around, if it's continuously changing, it will learn that it is changing over time and it is expected like a daily pattern. So it is learning what is expected and what is not expected. The variance monitoring is sometimes you have a parameter like with a variable bitrate that is continuously changing up and down. And if suddenly that's, you could say that noise is stopping, and it no longer changes, making a variance, and it goes for a flat line, then it would generate an alarm as well, or the other way around. So that's the variance change that it can detect. A level shift is basically when it's continuously around a certain value, and all of a sudden it makes a big jump, which is not expected. I say not expected because if it is something that happens every night, it will learn about that, and it won't generate an alarm on that. It will only generate an alarm if it's an unexpected, if it's an anomaly. Same thing for the variance. If it's continuously changing between variable bitrate and a constant bitrate, it won't generate an alarm each time it does. It learns about the behavior of that parameter, what is expected, and based on that, it will learn when there is an anomaly. We are talking about an anomaly detection, not just about any level shift. That's anomaly detection here. So only when it's an unexpected level shift, it will generate an alarm. So you can activate these kind of things. And that's actually quite interesting because some of these things are very hard to put in regular thresholds, like the variance monitoring. It's nearly impossible to put that, or actually impossible to put it in fixed thresholds. Level shift, same thing. If you want to have on a bunch of parameters, just have an anomaly detection. It's sometimes difficult to have it with regular thresholds. Okay, so those are a couple of more advanced options that are available there underneath that settings wheel. Now, you can also actually activate some scheduling, basic scheduling on a template, and you can do so by opening up the header of your template. So the template that you have open, you have a show details there. If you open that up, you are actually able to see some details, the name, the version, which elements are using it. And here you can configure the scheduling, and you can say it's by default, it's always active, or it's only active on specific days. For instance, this is has to do with a channel which is only in the weekdays active, and it's only active from like 8 o'clock in the evening till midnight. You can add more of those, but that's the possibility to say like, okay, only during specific times of the day this alarm template is active. I will just cancel that because I want it to be continuously active. Note that there is also a possibility, of course, to rely on the full scheduler that is available in DataMiner. This is a basic scheduler that is available embedded into a alarm templates. But also the scheduler of DataMiner is able to assign and deassign alarm templates as you wish on certain times of the day or any scheduled time. Okay. Another nice feature that allows you to make sure that your alarming is as accurate as possible is the conditional monitoring. It's the possibility to actually say that certain parameters should only be monitored under certain conditions. Or I should actually say it the other way around, that the monitoring is disabled if a certain condition is happening in your system. If you have like a satellite receiver and all of a sudden the input signal is gone, you will generate an alarm on the input signal. But yeah, you have a whole bunch of other parameters you're also monitoring, and all of them will also generate an alarm because the input is gone. So basically you're generating maybe like 10, 20 different alarms for one single problem. So therefore you can actually say like, oh, let's just say like all the other parameters, what I will do is I will say that the monitoring is disabled if my signal is gone. Then no alarming needs to happen, and only that one single parameter with the input status, if that one is okay, no problem, the other ones will be monitored. If that one goes into alarm, I generate that one alarm, and all the other ones are not alarmed or not monitored anymore. So that's actually a quite useful feature to make sure that you only have the root cause of the problem being alarmed. So you can add a condition in there, create a new one, give it a name, specify the condition, and you can easily reuse it amongst the different other parameters. So let's say I only want to do monitoring of my left, right, and output gain here of those parameters when my LMB1 supply is on. If it's off, I generate an alarm on the LMB1 supply, and I know there's a problem, and it has no use to also generate an alarm, for instance, on the other ones. So let me just move that a little bit like this. So I have the conditional monitoring. So the monitoring is disabled if the condition is true. So what I will do is I will add a, let me move it a little bit more. So I can just add a new one in there. You can actually support multiple conditional monitorings. So I will add a new one in there by clicking on the drop down. There are no conditions yet, so I have to create a new one. LMB off. So if the LMB off, then the monitoring should be disabled. So I go for that LMB1 supply, and I say if my LMB1 supply is equal to off, that's already perfect. So then I know the signal is gone, and then no monitoring should be happening on this signal or the output gain here, for instance. And I can, of course, easily reuse the LMB off on this one and on this one as well. So as soon as my, let's say, input here, LMB one supply, so as soon as this one goes into alarm, the input is gone. It's I know there's a problem. It's sufficient to say this alarm only. That's insufficient. All the other ones are just consequence alarms, you could say. So let me apply that one, and let me open up my device. So if I generate an alarm on my output gain, it goes into alarm. I have an alarm. Also the left test level if I generate or trigger an alarm, I do have an alarm. I already have 2 alarms on my IRD2. Now let's say that my LMB1, my input drops away. So the LMB1 supply, let me force that one into alarm. So I expect a 3rd alarm. Well, yes and no, I expect that 3rd alarm, but I also expect the first 2 alarms to disappear. So you can see I clearly have 1 alarm. My LMB1 supply has a problem, and therefore the other ones are no longer in alarm because they actually have no sense, or it doesn't really make sense to do the alarming on these ones. I know the input is gone. So the conditional monitoring really allows you to declutter your alarm console and to make sure that consequence alarms, you could say, are not being generated. I give you now the example of more like a root cause and consequence alarms, but of course there are many other examples where conditional monitoring is applicable, where you can say like, okay, it only makes sense if I monitor this parameter if another parameter indicates this or that. Okay, so keep that one in mind. Now, I've been configuring some of the alarm template changes continuously in the alarm template editor. That's typically where I will create my alarm templates and manage everything. But there are a couple of shortcuts to quickly do a quick change to an alarm thresholds, because alarm thresholds, that's something you continuously need to further fine-tune, and it's something you need to say okay, something happened here, maybe I need to refine the thresholds. Therefore, you can actually right click on an alarm. If you see an alarm and you want to change some thresholds, you right click on the alarm, you say change alarm range, and you get this pop-up. Or you can also double click, if you have the data display open, double click on the parameter, go inside the parameter. Let me show you. Let me maybe go back for a regular audio output parameter there. So I have, for instance, my output gain 15. I say yeah, well, 15, maybe that should be changed. 15 should be normal, or let's say a warning alarm. You can easily do so by right-clicking on here and say change alarm range, and it gives me the pop-up, and I can change that 12. I'll say okay, let's put it on 18, and let's put the 12 on a warning. And I can just update the alarm template, and it gives me a confirmation that there are actually a bunch of elements using this alarm template. Also, IRD1 is using it. Yes, you can do that for all of them. That's a general optimization of my alarm templates that I'm doing. So now I've updated nicely that alarm template, and I still have that delay on my alarm. So that's a quick shortcut right from your alarm console, but you can also do so when you're working with an element. You can double click on the parameter, and I do have that templates page, the last tab page here. I do have the possibility to also do it in here. I can change the 18 and further refine it, or maybe also add a major zone in between there to make it a little bit more gradual, you could say. And what I've not mentioned, you can update the alarm template, but you can also update this element only, because previously when I started from the alarm, I said update the alarm template, and was 10-20 of those elements using that alarm template and updating are now updated. You could also say, yeah, but IRD2 is a little bit a special case, and I want to actually make a duplicate of the alarm template only for IRD2. Well, you can do so by clicking on the update this element only, and you can then specify a new name for the alarm template, the duplicated alarm template, that will automatically be assigned to this element. So that's a quick shortcut to make a duplication of an alarm template and have its own thresholds for this one. Okay, so that's a quick shortcut to make the alarm template thresholds easily available for editing right from your alarm console, or by double clicking on the parameter and drilling down onto it, and you can immediately change the more basic things, not the auto clear and things like that. Therefore you still need to go to the templates. Now, assigning my alarm templates, I've already assigned it to my Microsoft element before by opening up the element wizard. So you can, of course, just in the surveyor, right click on your element. It opens up your the editing of your the edit wizard of your element. So I can also do it from the hamburger menu of this device. I click on the hamburger menu, click on edit, and you can here choose the alarm template that you have in there. So also the no monitoring is available to have no monitoring on there. You can also start from here an alarm template, and you can choose any of the available ones. And also from here, you can open it up as well. So that's how you can easily assign it. Let me close that down again, and let me start from the protocols and templates here. Let me go to the protocols and templates once more with my Microsoft platform and the BERT training that I created before. Well, on the right-hand side, you can see the elements that are using this template, and I assigned it previously by going to the edit of the Microsoft element. But if I also want to assign it on my second element that I created before, how can I do so? Well, simply over here, you can click on the assign elements, or you can also use the right click and assign template. And it gives you a pop-up with all the Microsoft servers on this system. And I can see already my second device there, and I can just add it to the elements that are using my BERT training template. And I close it, and I will see that now also this one has monitoring. So I already have two of them that are using this BERT training. And also, maybe not that visible, but you can see it over here. So it indicates also two elements are using the BERT training. Two of them are using the standards, and actually there's nobody using the no monitoring. So all my servers are being monitored one way or another way. So that's how you can assign it in the edit wizard or right from your templates while working with your templates. There is an exercise indicated here. I won't go through this exercise. We have done that basically throughout the demo here and there. Now, as a final step, I do also have that alarm template groups that I want to specify, or that I want to discuss. What is an alarm template group? It is basically allowing you to take several alarm templates and stack them on top of each other. In essence, what I want to do is I want to create a base alarm template that has, like, let's say, all the general parameters, the biggest chunk of everything that is always being monitored on these type of devices. And what I will do is I will add an overlay for parameters that might be different for one or the other case. Maybe I have some HD encoders and SD encoders, or a device that is capable of doing both. And depending on the input, it's either HD or SD. And of course, like parameters like a bitrate will largely be different. So yeah, either I take an alarm template that has very wide limits. Maybe that's not a good idea. Or I can take the alarm template, duplicate it, and basically have several separate thresholds. But what I did with duplicating the alarm templates is all of the general stuff, like for a power supply or the temperature or a CPU load, all of that is also being duplicated. And if you want to change something to one of those general parameters, you need to change it in all the ones that you duplicated. So you get what I'm trying to say here is that basically for the management of your alarm template, it might be good to only define your base once in an alarm template, and the special parameters you put in an overlay, an HD overlay and an SD overlay. And the overlays only contain a couple of parameters like a bitrate, these kind of things. And there, you hear me already saying maybe, I say it only includes a couple of parameters. So remember that column inclusion, exclusion, that will be something that is relevant now. So if I create an alarm template group, so I created a group here, the only thing I can configure is I can just add alarm templates in there, define a base and an overlay or one or more overlays, and it's basically from top to bottom that it will go through that to verify if it finds the parameter in the first template. If it didn't find the parameter because it's excluded there or it's not defined in there, then it will go to the next one, go to the next one until maybe it didn't find it anywhere, then it's no monitoring, of course. At the bottom, you see what the result is by combining those different thresholds. Let me maybe show you first an example on our demo system. I'm on my demo system, and I do believe that I have somewhere here an example. Yes, with the alarm template grouping. I have a video bitrate here of an HD that's 15, and I also have the SD which is around 5 megabits. Well, if I take a look at the configuration, you will see that if I go to the edit, that this one uses the SD group, while the HD one actually uses the HD group. Let's take a closer look at that. The HD group has a base with an HD overlay on there. And if I would take a look at the let me open it up like this so that I can easily open up the other ones as well. So you have the base and then you have the HD overlay. Let me cancel that one and cancel that one. And open up this one. So I do have a base. If I open up the base, I will see that there are a lot of parameters in there. That's the base, and most of the things are being monitored in here. All the ones like the temperature and things like that, that's general stuff. But if I take a look at the SD or HD layer, let's go for SD layer. If I go for the SD layer, then I will see that the video bitrate is included here, and it's like 5 expected. And the video input has certain values. If I would go for the HD layer, it would have 12, and it defines some different thresholds here. And only those ones are included. So if I show all the parameters, you could see that all of them are excluded. So I basically removed everything from this alarm template, and only 2 of those parameters are included and are basically my overlay. So the overlay is typically an alarm template with only a few parameters in there that I want to overrule on top of the base. Now, if I take a look at the HD group, so if I open up the group, you will see the group. That's very simple. You can add different alarm templates in there. We've added the base. You can remove it and move it up and down with the arrows. We added the base at the bottom, and we've put the HD layer on top. We will go from top to bottom. So if we find the video bitrate in the HD layer, we will take it from there. The video bitrate is in there. If we take the temperature, it's not defined in the HD layer, so we will take it from the base that is underneath there. So that's how it works. And that's also shown here with a quick example. I have some parameters like parameter A, B, C, D, E. And I have a base template over here that is defining certain thresholds. And I have an overlay 1, and I actually have an overlay 2 as well. The overlay 2 has only 1 parameter included and actually defines no monitoring. So parameter C is defined by this overlay 2. That's the result, is at the bottom here in bold. The second overlay has some other parameters included. So those ones are then taken, the parameter A is taken from overlay 1 because overlay 2 didn't have it. So that's the winning alarm template, you could say. If it's not defined in any of the overlays, it's taken from the base template, of course. The base template has everything. If it's not included anywhere, it's not included in the result. There is no monitoring as well. So that's how basically the base typically has everything. And then you have overlays with a few parameters in there, and it goes from top to bottom. So that's how a template group looks like. So here the allow inclusion exclusion comes into play and is an important column that you need. So you only include one parameter, for instance, and then you typically just define the thresholds on there. The base template you will define more, of course. If you want to create a new group, you simply right click on any of those, you go for new again. And there you can specify the name of your group, like Bert group. And the other things are, I almost forgot. Of course, I'm creating a new, not a new alarm template, but I'm creating a new alarm template group. So I need to specify here now that group. I created an alarm template before. So I create a group, give it a name. I'm fine with that protocol, of course, because I'm working here on that Stamberg. And I can simply have alarm templates added in there. That's the only thing I can do. It's very simple. I can just add an existing one, the base, and I can add the HD overlay on top of that. Oh, it's adding it below it, so I need to move it. So I move it on top, and you can see the result that is being shown here at the bottom. So I will find somewhere that video bitrate that is in there, but I'm not sure which page. There it is. No. Yeah, anyhow, here it is, video bitrate. The video bitrate of 12 is coming from my HD layer. If I would move it below it, your video bitrate is now no longer correctly monitored here with the 12. You need to make sure that your HD layer is on top of that, and then your thresholds with 12 are correctly defined in your HD layer and are applicable if they are on top, of course. And of course, you can save that and apply that to your element, just like you assign a regular alarm template. So an alarm template group is allowing you to make a little bit more, you could say, thresholds reusable across different. Instead of duplicating the full alarm template, maybe you should work with the base and have some alarm overlays on top of that combined in a group. But of course, remember in this case with the HD and SD example, I could also use the normalization of the parameters as well, of course. So depending on the situation, one or the other might be applicable. But remember that the grouping might come in handy to have some good management of your thresholds. So you can see the result here at the bottom of combining several thresholds together, or alarm templates together in this group here. All right, so this was the alarm templates. There's a lot of configuration we have covered. Step by step, we created our alarm template, and first, very basic, activated some checkboxes and some thresholds to apply it already. Then we went the matrix. I've shown you the matrix. We went into a table of the task manager with the filtering. That was, of course, an important one as well. And then we had some different, more advanced options, you could say, but definitely hysteresis is an important one. You have the information column. You also have the conditional monitoring you can add. You have the auto clear even you can configure. So you have a whole series of different possibilities, but also remember, of course, that normalization with relative and absolute, the rate alarms, you do have quite some functionality and quite some features here, but that is also because alarming is very, very important in a DataMiner system, and even more important is to have correct alarming. So keep in mind that working on your alarm templates is a continuous thing to do, and further refining it should be done on a continuous basis. And you can easily do so by right-clicking on the alarm and going to the alarm range, or drilling down into your parameter as well. Okay, so I hope that gave you a good solid base of the alarm template knowledge. Let's go for the next one, which is trend templates. That's easier.